Hi everyone, today's notes are on section 4.9, which is the best method for solving quadratics. So over the past couple of days in class, we've learned about a few different methods that you can use when solving quadratics. This front side of the worksheet outlines 4 of the different ways that we've learned about. So you've got the square root method, you have the factoring method, you have completing the square, and then finally the quadratic formula. The front side of the notes today goes over one example of each of these methods, but in the middle column here, you also have some notes about when each one is going to be the best method to use to solve a quadratic. So here for the square root method, it says that you'll use the square root method as the best method of solving the quadratic equation when the equation doesn't have a b term. And so looking over here in the example column, 4x squared minus 48 is equal to 0, you'll see that that equation is a quadratic equation and does not have a b term. And so we'll follow the instructions here on how to solve this given example. I'm going to move the c term to the other side of the equal sign, and then I'll divide by the coefficient 4 to isolate the x squared term. X squared is now isolated, so I'll take the square root of both sides, and then I'll remember the plus or minus on my answer. For this one though, the 12 can be simplified. The square root of 12 is the same thing as the square root of 3 times the square root of 4, and then the 4 comes out as a 2. So my final answer for this one is going to be x is equal to plus or minus 2 square root 3. In the next set of examples, each of these is going to be best solved by factoring. You can solve a quadratic equation by factoring either when the equation has a GCF that can be factored out or when the equation can be t-charted, and sometimes they can be factored both ways. So here on this first example, to solve this one, I'll start by factoring by GCF. So I'm going to divide out the GCF. Once I have the equation written in factored form, I'll use the zero product property to set each factor equal to 0 and then solve. And so for this example here, I'll get that my two answers are x equals 0 and x equals positive 4. The next example on the notes is also best solved by factoring because it can be t-charted. Remember, when you solve by t-charting, you're looking for two numbers that times to give you x squared, so that'll be x and x. And then the two numbers that times to give me 3 but add up to give me 4 are going to be positive 3 and positive 1. I'll write my equation in factored form, and then I'll use the zero product properties to set each factor equal to 0, and then I'll solve. And so for this one, my two solutions are x equals negative 3 and x equals negative 1. Moving along, sometimes quadratic equations are best solved by completing the square. You'll know that completing the square is the best method to use when the equation has a b term and the coefficient of that b term is an even number. So looking over here, the coefficient on the b term is the number 8, and so 8's an even number, and that's why we'll know that completing the square would be the best method to use to solve this quadratic equation. And so I'll follow the steps here for completing the square. The c term is already over on the other side, so now I'll make the space. Remember, to fill in that spot, I'm going to take half the b term, so half of 8 is 4, and then I'll square it, and so 16 is the value that I'll add to both sides on this one. The next thing I'll do is I'll t-chart the left-hand side of the equation. 4 and 4 are the two numbers that multiply together to give me 16, but add together to give me 8x. X plus 4 quantity squared means I can take the square root of both sides. That'll leave me with x plus 4 is equal to plus or minus the square root of 17, and then I'll finish by minusing the 4 from both sides. And so for this one, my final answer will be x equals negative 4 plus or minus the square root of 17. In the final example on the front side of the notes, sometimes none of the other methods work, and so the quadratic formula is considered the best method to use to solve a problem when the equation has a b term that is an odd number and the equation cannot be factored. To solve by using the quadratic formula, I'll start by making sure that the equation is set equal to 0, and then I'll plug in the a, b, and c values into the quadratic formula. And then once I have those values substituted, I'll simplify. 7 squared is 49, 4 times 5 times 1 is 20, and then 2 times 5 is 10, and then I'll simplify the inside of the square root one more time. And so here I'll arrive at my final answer for this example. X is equal to negative 7 plus or minus the square root of 29 over 10. Considering these notes all together, what all 5 of these examples have in common is they all have squared terms. What's different about them is whether or not they have b terms, whether or not they can be factored, whether or not the b term is an even number, or whether or not the b term is either an odd number and that the equation cannot be factored. Moving on to the second part of today's notes, we have 6 quadratic equations, and our goal here is to describe which method we would use to solve each quadratic equation, explain why that's the best method to use, and then solve. So looking at example A, we see that it has a b term. That means we know we cannot solve it by the square root method. In examining the equation, we see that it has a GCF, so I could factor the x out of both of those terms. And so for this one, we're going to solve it by factoring. And here factoring is the best method because it has a GCF that can be factored out. Once we've decided that factoring is the best method to use to solve this quadratic equation, we'll go ahead and solve it. So I'll start by GCFing out the x, and then I'll write the equation in factored form, and then I'll use the zero product property to solve for each 0. And so my solutions for this first equation are x equals 0 and x equals negative 9. On example B, the equation has a b term, so I know that I cannot solve it using the square root method. If I move the terms around to have it be set equal to 0, I'm going to have x squared minus 2x plus 1 is equal to 0. Notice here that my b term is -2. That is an even number. So I could solve this by completing the square, but completing the square isn't the most efficient way of solving it because this equation can be factored. So here on b, I'm also going to solve using factoring. And the reason for that is because it can be t-charted. And so when I do my t-chart, x times x gives me back x squared, and then -1 times -1 gives me back +1. But then when I add up my cross products, they give me -2x. I'll write my equation in factored form, and then I'll use the zero product property to set each part equal to 0. Because the factors match, I only have to solve for one of them because this side will be the same. And so my single solution for this one is x equals +1. All right, moving along, for example C, this one has a b term. Notice that the b is an odd number, so we know that completing the square would not be the best method to use to solve this equation. We could use the quadratic formula, but again on this one I'm going to choose factoring, and the reason to choose that is because it can be t-charted. Now this t-chart's a little bit trickier. I'm looking for two numbers that times to give me 5x squared, so that's going to be 5x and x, and then I'm looking for numbers that times to give me 4, but when I multiply the cross products with the 5x and the x, I have to get 9, and so that's how I'm going to decide that the 4 goes here and the 1 goes here. 4 times 1 gives me 4, and then 5x plus 4x gives me 9x. I'll write the equation in factored form, and then I'll use the zero product property to solve for each of the zeros. So I'll get x equals -4/5 and x equals -1. So x equals -4/5 and x equals -1 would be my two solutions for this one. It's worth pointing out that C was a little bit trickier of a t-chart, and so you could have used the quadratic formula if you were struggling to come up with the numbers that worked in the t-chart. All right, moving along to example D. So example D has a b term, and it's an even number. This equation cannot be factored, and so because the b is even, I'll solve by completing the square. Again, helpful to point out here that you could solve using the quadratic formula, but completing the square will be a faster way of solving it. So when I solve by completing the square, I'm going to move the constant 7 over to the other side, and then I'll create the space. Remember that to fill in that space, I'm going to take half of my b term, so half of +4 is +2, and then I'll square that, and so 2 squared gives me 4, so I'll fill in the 4 on both sides. I'll t-chart the left, I'll take the square root of both sides, and then here I'll stop because negative the square root of 3 means that this has no real solutions. And again, remember what we're solving for here is x-intercept, so that means that this quadratic equation, if you were to graph it, just wouldn't cross the x-axis. Remember, no real solutions is because we got a negative underneath the square root. All right, last two. So on example E, notice that this equation does not have a b term, and so because it does not have a b term, I'm going to solve it by the square root method. And so again, anytime the equation doesn't have a b term, the square root method will probably be the easiest method to use to solve it. And so I'm going to add the 9 to both sides, and then I'll divide by 16. I have x squared equals 9 over 16. Once the x squared is isolated, I'll solve by taking the square root of both sides, and then don't forget the plus and minus on your answer. The square root of 9 is 3, and the square root of 16 is 4. And so my two solutions on this one are going to be x equals plus or minus 3/4. All right, and then for the last one, this equation does have a b term, so I know I can't solve it by the square root method. Notice that the coefficients are 2, +6, and -36, so all three of those can divide by 2. If I factor out a 2, I'm going to be left over with x squared plus 3x minus 18, and then that expression can be t-charted. It's almost like you have to try t-charting it to see if you can solve it by factoring before you would decide on this one to use the quadratic formula. So I'm going to solve this one by factoring because it can be t-charted. So I factored out the 2, and then I'm going to t-chart what's left over. So two numbers that times to give me -18, that add to give me +3 are 6 and -3. I'll write my equation in factored form, and then I'll use the zero product property to solve for the two zeros. And so my two solutions for this one are -6 and +3. Before we finish for today, it's worth pointing out that none of these had the quadratic formula as the best method, and that's worth noticing. Usually the quadratic formula is only the best method when nothing else works, and part of that is because the quadratic formula takes the most time when it comes to plugging in your a, your b, and your c values. So remember, we're going to use the quadratic formula when the equation has a b term that's an odd number and the equation cannot be t-charted. So think about the quadratic formula as kind of being like your last method.